Welcome back, everyone. Now we're going to shift gears a little bit, and we're going to talk about testing for food contamination, looking at the whole picture. And our thought leader joining us today is Carla Kinslow, PhD. Carla's the director, toxicology and food safety for the Rimkus Consulting Group. She has over 31 years of experience in this space. Carla manages a team of toxicologists and other scientists, including a veterinarian. And in her spare time, she loves brewing her own beer, which if we weren't virtual, we'd be tasting it right about now. Take it away, Carla.
Thank you, Stephen. And thank you all for being here with me today. Today, we're going to talk about testing for food contamination. We're going to look at the whole picture, okay? This is how we approach many of our cases. Next slide, please. We're going to start with how the contamination got there. We really do look at all the different points in the process from the time it's sourced to the time it is eaten. And it's really important for us to understand that before we start testing all at one time. And mainly, we start with a traceback investigation. What that is we go back in time. Where was that food? How did it get to that plate? How was it sourced, etc.? And that type of information helps us identify where we want to start in our investigation. We also start with the condition of the source material, depending on what condition it's in, frozen, how old it is, the way it's been stored. It really depends on how we go about testing that. What is available for testing? What will work? We don't want to waste your money. And a really cool case we had, THC-laced barbecue sauce, is a real good example of that. So this is what happened. We had a client call us up and said, we had a whole group of people from this one company that got sick after a pitch-in dinner. And the company had provided the meat, and then other people brought the extra stuff to pitch in. After some study regarding their medical records, they recognized that they had been exposed to THC, which is the psychoactive component of marijuana. Now, THC is legal in a lot of states, and so we were really interested in where did they get the THC? Was it from, say, a cow that ate marijuana? We don't know. And so we looked at the meat, we looked at the sauce, and we looked at the preparation. Three different individuals, three different groups that could be responsible. And we found that the one person that was very protective of his sauce was an employee that provided that sauce, and it did test positive for THC. So it wasn't the meat that the company had bought or the preparation, it was the employee that brought the sauce. Next slide, please. So the other thing is we get a lot of materials in food, broken teeth. That happens about 3 or 4 times a year in our casework. And what we do is we, first of all, we're like, that's gotta hurt. The other thing is, when did that tooth really get broken? Did it really coincide with when they ate that food? And the other question we get is, was it really in their mouth? We can test. If they said that, oh yeah, it was in their mouth as compared to something that was placed in the food, we can look for specific enzymes that are identified only in saliva. And then where was that screw made? Meaning, what material was it made from? And so we go to the materials experts and we say, hey, is this a stainless steel screw, or is this something that you'd find on your roof? And if it was a stainless steel screw, maybe it wasn't identified in your restaurant. There are certain types of materials that are only identified in restaurant grade machines and facilities. So we understand that, and we can look at that. Next slide. Salmonella. Did you know that there's a basal or background level of salmonella infections throughout the public right now? And we only get notice of spikes every so often. That salmonella is incredibly proliferative in the environment, and that we can handle, most people can handle a certain amount of salmonella infection. When they gets too much, that's when we get really sick. And there's numerous environmental sources of salmonella. The other thing is that many people say, oh yeah, I ate somewhere and then a couple hours later I got sick. But a salmonella infection can occur hours to days after exposure. The other thing is, was that person really diagnosed with salmonella? Salmonella causes really bad stomach. It's a very bad infection, stomach cramps, diarrhea, things like that, which are common to other types of infections like the flu. And what we do is we look into that medical record and see if that person was truly diagnosed with salmonella in their blood or in their stool. Sometimes they haven't been, and the doctors simply go by whatever that person has claimed that they're having an issue with, and they're treating that person. It might be the same as treating someone for the flu or some other type of illness. Next slide, please. Slow flow can allow microbes to grow. The fact is that, for example, up here in the top right-hand corner in that red ring is a dead end or a dead leg. What that is it's a place in the piping, say for an industrial facility that produces food, any type of liquid that can go through piping. It can get lodged in that area, and things are not completely sterile all the time. There are going to be some sort of microbes that might be in there, and once they find that slow spot, they can start to proliferate and grow, and that can be a colony that can then contaminate the rest of what's going past it in that line. The other thing is we have a really good understanding of biofilm development in piping. Basically, you can see here in the bottom left-hand corner here, the cells actually attach to the pipe, and then they create this matrix of cells and protein and sugar structures. And then it pulls in other molecules into it as well. It becomes a layered structure. And then after a certain period of time, due to the stresses of the liquid going past, there will be migration and sloughing where it goes on, and it creates this longer piece of biofilm. Next, please. Bring up, not the next slide, but thank you. And then if that biofilm stays long enough, you can actually get pitting and corrosion. And this is where I see sometimes in my beer contamination cases where a client might think that allowing a clean in place decontamination cycle is all they need forever. It's not. They need to actually physically change out the piping or change out other parts of the system in order to clean it properly. The O-rings, you have to go through a really good cycle of physical cleaning in order to clean that piping out. So slow flow allows your microbes to grow. Next slide, please. Evidence. This is the one thing that severely limits us. Sometimes they ate it all. Sometimes they threw it all away. Sometimes they lost it. It was a couple of months ago, and it was in the back of the freezer, and we cleaned our freezer out. We get a lot of that type of information. But we can still help you guys. We can look at those medical records. We can kind of verify if some of this is really what they're alleging is really going on just by a desktop review. And even if it's been left at room temperature where it's moldy, frozen, and it should have been refrigerated, all these we can possibly help. So please give us a call. Next slide, please. So in summary, the better the better we understand what can help you and how we can help you. Good evidence means good opinions. Appropriate testing, again, gives us a high certainty on our opinions. And is that claim reasonable? Did they really have salmonella infection or something else? Or did they break their tooth a month before? Thank you all, and I look forward to speaking to everyone during the panel discussion.
Wow, thank you very much, Carla. That was fascinating information, and the questions you raised are terrific. We're really looking forward to hearing the deeper dive because you've raised some really, really good thoughts here. So thank you for that. Okay, everybody, we'll talk to you next time. Bye for now.